So this third lecture is actually about refining the mesh. So there are some techniques that are used for refining the mesh. Refining the mesh means what? The refining the mesh means we need to go for meshing that mechanical object or part in such a way that the outcome of which are going to be very nearer to the actual physical results. We need to reduce the errors, we need to move nearer to the actual, and for that purpose we need to refine the mesh. Refine means we will change the mesh, we will change the structure of that, we may change the type of element, and so on. So, what are the types? What are the things that are done for refining the mesh? Is our topic. Actually, from the exam point of view, also this is important because what are that particular things that are done for refining the mesh? This is one question asked in exam. So this is also one of the important topic from the exam point of view also. So the accuracy of FEM depends upon the mesh quality, right? The use of finer mesh and higher order elements improve the accuracy of FEM solution. It is, of course, and we learned that many times in previous sessions. So what to do there for that? For improving the accuracy of FEM solution, following four methods of mesh refinements are used in discretization of meshing. What are that four methods? That four methods are named as, first method is H refinement, second is P refinement, third is HP refinement, and fourth is R refinement. So as I'm saying you that this is important from the exam point of view, so you need to remember this four, and you have to list that four first. Then you explain that one by one. Like if I go for H refinement, what this H refinement means? The H method improves the result by using finer mesh of the same type of element. General statement. What is the meaning? The method refers to decreasing the characteristic length H of element. Decreasing the characteristic length H of elements. This is the main part of this H. How to decrease it? You can decrease that by dividing each existing element into two or more elements without changing the type of element used. How to do that? So for understanding that, I am showing you some images. You just see that there is a original mesh, very simple mesh I am saying for the sake of understanding. So this is the original mesh that you have, and in this original mesh, if you can see my cursor, I need to apply this H refinement. So when I'm going to apply this H refinement, then the result is going to be like this. Can you see the original mesh and H refinement? So in original mesh, suppose if I take this element, left element of the bottom edge, so if you see that element in original mesh, and if you see that element in the H refinement, you can see that there is a extra node that is added. You know? Extra elements are added in between. So in this square also you can see that there are extra elements that are added. And in this way we are going to refine that. What will be advantage of that, what will be disadvantage of that and all, we are not here discussing that. But what is H refinement, that we are understanding. So now we can see what is the H refinement. It is increasing the number of elements. What is actually the effect of this on the equations or on the overall behavior, and that we will discuss that. We will discuss that also in detail. So more accurate information is obtained by increasing the number of elements. We are doing that for obtaining more accurate information, more precise information. So the name for the H method is borrowed from the mathematics. So this why this H is used. Why this H uh, word alphabet is used for this method. The variable H is used to specify the step size in numeric integration. So when you will go for numeric integration, integral calculus, the H is the alphabet that is used for specifying the step size. So here we are increasing the step size, therefore H is the alphabet used for this method or for the name of this method, for terminology of this method. If a part is modeled with a very coarse mesh means finer mesh, more number of element, denser mesh, then the stress distribution across the part will be very inaccurate. Coarse mesh. Coarse is actually related to the density. Density. So, coarse and fine, these are the two words that are used mostly for representing that density. So, coarse, meaning of a coarse is less density, and meaning of fine is uh, higher density, right? So finer mesh, coarse mesh, these words you will heard, okay, in coming uh, concepts, coming units also. In order to increase the accuracy of solution, more elements must be added. That means this means creating finer mesh. Can you see this word? Finer. Coarse mesh is going to be uh, come out with the stress distribution across the part, which will be inaccurate. Coarse means less dense, whereas finer mesh will give you accurate values. So if you see that in analogous form of statistical buildings, right? So with coarse mesh, you can see the number of elements are less, whereas in fine mesh, number of elements are more. So you are getting a fine or accurate result. Here the result you can see is deviating from the actual. There must be one curve here nearby, which will showing the accurate curve in both diagrams, so that you can compare that which curve is nearer to the accurate curve, and so. So this is actually mathematical tooling to understand the concept. What actually we are making accurate is the physical entities that we are coming out as a result of some stresses, of some physical activities that are done. Like if you are applying some force, it is going to be get displaced, it is going to be get deformed. So the more accurate deformation, more accurate stress value, more accurate the velocity of the fluid, more accurate the frequencies of the vibrations. That accuracy I'm talking about. Here it is shown by in the curve form to understand that concept. So if I go for the more about H requirement, so it is as an initial run. A coarse mesh is used to model the problem. A solution is obtained. It is for comparison actually. To check this solution, a finer mesh is created. How to go for making creating the finer mesh and all, we will see that in the practical session. And very soon, I think in the next week or onwards, we will have our offline lectures in class, and also we will have our practicals that will start. So in practicals, we will see that coarse and fine mesh, how to create that fine mesh from the coarse. The mesh must always be changed if a more accurate solution is desired. So here, whatever written is, if you go on creating the finer and finer mesh, if the coarse mesh is converted to finer mesh, you are getting a result. Then again create the finer of finer mesh, then get the result. In this way, you get the result in such a way that the change in the result then after will get stagnated. Stagnated means it will stop, or the change is very minute. Change will be very negligible, less, and at that time you can conclude that the accurate results are achieved. This is one of the process that is done and enhances actually the automated process which runs these particular steps is also available. So, if possible to us, and if that is there in our practical syllabus, we will do that. So, this is the comparative I shown for H refinement again. Okay, so refining, finer mesh. You can see the word refine. Refine means again finer mesh is used. Fine mesh is used. Refine, refinement. So going for P refinement, so understanding this P refinement, second, right? Second case in which in the P method, what is done? It improves the result by using the same mesh, but increasing the displacement field accuracy in each element. What is the meaning of this statement? It means that this method refers to increasing the degree of higher complete polynomial, higher order polynomial, in other words, within an element without changing the number of elements used. So, if how to do that? Higher order element means, if you remember the previous sessions, you just revise it that higher order means if two node member is there, we have to make it three node, right? Increasing the number of nodes will make that of higher order, and because we are using, because that is actually increasing the order of polynomial and it represents polynomial, therefore this P alphabet of represent polynomial is used for this particular refinement, P refinement. So how to increase that? I'm showing it again, comparing it with the original mesh. So you just compare that in case of H also, last case. And here original mesh, same mesh I kept here, original. And when if it is applied P refinement, it is applied for P refinement, then this will be the changed or modified mesh. What you can see here is this 2D element is now 2D element means two nodes element is now three node element. It is not 3D element. It is three node element now. And each element in this, you can see the nodes are increased. Elements are not increased. So the difference between two methods lies in how these elements are treated. The H method uses many simple elements, and number of simple elements increased. Whereas a P method uses few complex elements. Getting my point? Where here the elements are few only, but we have made it complex. If you increase the order of equation, you are making it complex. So here simple elements are there, but they are used in more numbers. Here complex elements are there. Sorry, small no, elements are there. Few elements are, but the complexity is increased. Like this is the comparison that can be done for H and P refinement. See, this explanation are what I'm explaining here in the video, as I'm saying again. I'll edit this part, whatever I giving you. Uh, you concentrate on the explanation also during watching the video again and try to convert that in notes also. Why? Because this type of questions or this type of concept, they are not going to ask in exam like list out that four methods and explain. They may ask that question in a way that what is the comparison between H and P method. So if I go for the next explanation for this P, then P method stands for polynomial, as I explained already. Large numbers and complex shape functions are used in P method problem. Obviously, complex equation will get created. So in order to increase the accuracy of solution, the complexity of the shape function must be increased. So increasing the polynomial order increases the complexity of the shape function. The mesh does not need to change when using the P method. Mesh is not to be changed. Only we are going to increase the complexity by increasing the number of nodes. So if I see here this straight line, can you see actually this curve resembles like a polynomial, but if you increase the order of element, this curve which is the polynomial before, you will find that it is touching to the actual and very nearer. Can you see? So this is the analogous explanation and analogous understanding of this concept of P refinement. Here actually is explaining for second order and third order. Will not reach to third order, it is very complex. Even if you are reaching to the second order, that is also difficult. So 1 to second order is the highest jump that we will have. But it is not mandatory for every time that only second order is to be reached. Third, fourth, fifth is also reached. And because this software also have the industrial application, they go beyond that also for getting the final result, accurate results. So in P refinement, as an initial run, the solution might be solved using first order polynomial. Same case here. Instead of course and then fine and then fine, here what we are using, we'll use the first order polynomial equation, we'll get the result. We'll go for a second order polynomial equation, we'll get the result. We'll go for the third order polynomial equation, get the result. And we'll go on changing the result in such a way that the results are very nearer and it is not changing more. In that case, we can conclude that now we have reached to the accurate value or nearer to the accurate value. So then next is HP refinement. So actually, this is given in your local book, and because mostly the paper setter and even the paper checkers are referring that, therefore I am including that whatever method given in that. Otherwise, HP method and R method is not discussed in other reference books. Only H and P. H separate, P separate. Here HP refinement. So as name indicates, there must be features of H and P both for this case. Isn't it? In HP refinement method, the number of element is increased as well as the degree of polynomial of element is increased. Both the things are done here, and therefore we are going to get this type of HP refinement. Can you see here? Element is also used, but here we have increased the number of nodes also. Can you see here? Here, if you remember, you can go for watching this video and reverse it and watch that figure also of H refinement. Also watch the figure of P refinement, and then you can go for HP refinement. Okay. So we can go for making that one slide also for comparing that three together on the same slide, so that you will get the idea that how this HP refinement works. Simple case, and therefore in HP refinement the advantages of both is going to be achieved. It depends on the element, it depends on the member, it depends on the analysis, which element or which refinement should be used. Now we'll go for the R refinement method, the last method that we discussed. In R refinement method, the accuracy of solution is improved by rearrangement of nodes without changing the number of elements or the degree of polynomial of elements. The degree is kept as it is, that means it is not P refinement. The number of element is also kept as it is, therefore it is not H element, right? In H element, number of element increased. In refinement, the degree of polynomial is increased, but both are not changed here in R. So then what we are changing? We are going to rearrange the position of node like this. Can you see? In R refinement, this central node, its position is changed somewhere else. Now, this type of changing of position is done for getting the values at that particular point. If that particular surface or that particular part of any member is critical, getting the stress concentration is more there or something like that. So in that case, if node is shifted to that location, it will be better for getting the accurate result. So here, instead of changing that two criteria, we are just rearranging or changing the position of node in case of R refinement. So this R actually stands for rearrangement. So therefore, you can remember that H stands for increasing the number of steps. P stands for polynomial, HP combination of that both, and R for rearrangement. So these words, if you remember, then you can explain this four method in detail with diagram, isn't it? Uh, we will go for the second next topic, the ending with this four refinement. So there are two more concepts that are used for refining and making the mesh finer. What are that is adaptive meshing. Adaptive meshing. So this is one of the term. What is this adaptive meshing? In finite element analysis, error always occurs due to some limitations. If such error is beyond the acceptable level, then it is very important that and necessary to refine and update the mesh, which we are doing. The meshing which is used to used for refining and reducing the error is called as adaptive meshing. So all four methods, what we see, can be called as adaptive meshing because all are going to reduce the error. So that is achieved in adaptive meshing. Automatic generation of mesh goes on till the error in meshing is minimized to acceptable level. So regenerating the mesh again, making it finer. I am showing here the diagram. Here the coarse mesh is shown here, where the fine mesh is shown here. Can you see the density of mesh here is less, whereas here it is very dense or density is higher. So this process in where we go on increasing the number of element either or degree of polynomial to get the more and more accurate result. This process actually can be achieved automatically, as I said in the previous slide also, in the uh, software with the help of adaptive meshing. Right? So adaptive meshing refers to a technique where the mesh density is dynamically adjusted during the simulation. It is automatically refining that mesh in areas, as I said. So, for example, I have shown that here in three cases A, B, and C, in where the mesh is going on finer and finer, density is going on increasing and increasing. Can you see one more thing here, that the density of mesh here in the A diagram you can see on the upper side and on the lower side is different. Even the density is not uniform throughout. Not only these two parts, but even if you take the right and left of this at the bottom, then also you'll find the difference in the density. Not very high, but the elements are not identical. Getting my point? So it can be achieved with the help of software also, that for the more accurate results, which type of machine must be there. It may be possible for us or for you in future days, or maybe the ANSYS or software inventors must be working on that, that to include the AI, artificial intelligence, to achieve this automatically with the help of that AI generated tools. And that may help for, actually what we are doing is we are making our job lesser and lesser. We just want to sit and see. We don't want to do anything, right? It is the nature of human, I think, and that is the nature due to which actually we face many of the problems. So don't go in that particular phase, watching and sitting and watching. Just go for doing the things, understand the concept, doing of your own, not copying the others. Even if I'm telling you that go for assignment, then it is not to be done by you, that you are taking the copy of someone, just seeing that what he has or she has written, and then copying that again and submitting it. That can be actually completion of assignment. No issue. And I'm not going to check whether you have copied or not. I'll just see whether you have submitted or not. That's it. But of your own, by keeping the professional ethics, by keeping the honesty, if you are doing that of your own only, by taking some efforts, by seeing the videos, by understanding that, by seeing some references, in such a way that if you are going to complete that of your own, it is going to help you, not for the mass. I'm saying for your future in your professional engineering life. So that definitely is going to help you, believe me. So this is adaptive machine, and I think 4, 5, 6 minutes are there. So we'll go for one more topic, one more point that is also asked in exam. That this part is what is adaptive meshing? This is the question mostly asked. Geometry associative mesh. So this is one of the points that we'll see, and then we'll stop for the attendance. Okay. Okay. So what is geometry associative mesh? In finite element analysis (FEA), the geometry associative mesh refers to the mesh where the individual elements are directly linked to the original CAD geometry. That can be achieved in the software actually. You can link them to the original CAD geometry, that mesh. So what is the advantage of that is whenever you are going to modify that CAD geometry, that shape of the part, size of the part, geometrical arrangement of that part, if changed, the mesh is all automatically will get changed according to that, because that meshing is associative. You're associated with the geometry. So this is the concept of geometry associative mesh. If that mesh is directly linked with the original CAD model, CAD model means what are the model drafted in either CAD software or in the ANSYS also. If you have linked that mesh to the geometry, if you, due to some reasons, if you want to modify that part, there are many steps comes where you need to modify the part, you need to modify the shape, you need to modify the surface finish, need to include the rib by seeing the stress concentration and all. So in such a way, if you modify the geometry, the mesh will get automatically adjusted with that according to that geometry. Okay, so what is the benefits of that? So benefits is efficiency, significant time saving when making design changes as the mesh automatically updates with the geometry modification. And efficiency will increase. Again and again, you don't have to mesh again and again when you are going to change the geometry. It will change automatically of its own. Accuracy, ensure the mesh accurately reflects the latest design. Of course, that connection with the geometry will increase the accuracy. Okay. And design iteration. This is one more important concept in design. This facilitated rapid design iteration. Design by iteration. You need to go for iteration 1, 2, 3, 4, 5, 3 turns, in which you go on making that design correct and accurate and optimum. So this iteration can be achieved with this step, which we call as geometry associative